Welcome back. We are now going to look at our correlation calculation worksheet. So if you kind of follow along, I'll tell you how I got my items from that. So we're going to find correlation, and that's the strength of the linear relationship between x and y when you plot some points. So I have our information here. We have number of children in a family for our x values, and we have number of televisions in that house. This actually comes from my relatives. So that's where our data comes from. It's real data. So I plotted those points on a Cartesian coordinate system. This is quadrant one. You can't see the other quadrants there, but that's quadrant one. And if you look at this, it kind of slopes up, right? The points kind of go up. Like we're going to say, if we had a line that went right in there, it's kind of like that, okay? So if the slope is positive, if it goes up from left to right, it's going to have a positive correlation. And correlation is stuck between -1 and +1. Zero's in the middle. Zero's chaos. The points have no line description whatsoever. We got a little bit going on here. It's not the greatest. If it goes downhill from left to right, we have a negative correlation. And if it's just random points, it's going to be pretty close to zero, right? There is no linear relationship between those. Later on, if you take a harder stats class like Stats 2, you might learn things like trying to fit a curve to this data, which might be better. We only make you do lines in this class. So in order to use this huge formula up here, don't be afraid of it, okay? We're going to do a little math by filling in a chart. So we have our x and our y values. Then we're going to square all of our x's and put those in a column. Now the y's have to match with it, okay? And the y's go in, I square those, and then we put those in this column. And then we have our xy's. If you notice at the very bottom, we want to sum those up. So for the sum of the x's, we get 16. And the sum of the y's, we get 19. And the sum of the x squareds, we get 66. Remember, sigma means sum. For the sum of the y squareds, we get 75. And lastly, for the sum of x times y, we get 65. So those are those major values we get from squaring each x, squaring each y, x times y, and then adding up the columns. All right, so we're going to take all those values and put them right in here. Now, n is how many pairs we have. So I have 1, 2, 3, 4, 5 pairs or 5 coordinates. So n is going to be 5. And then we plug in sigma xy, which we have right here, 65, minus sigma x, which is 16, times sigma y, which is 19. Now the math on the top is multiply first. Multiply n times sigma xy, multiply sigma x times sigma y, and subtract them. All right, do it in that order. In my denominator, you'll get a single number. In my denominator, remember, n is 5, and then I substitute my value for sigma x squared, 66, minus sigma x, which is 16, and then we're going to square it. All right, sigma x first, then square it. Then subtract these two. All right, n has to be multiplied first. Remember, multiply before you subtract. And we're going to get a single number. Okay, by the way, that single number is 74. Then we plug in our values for the y's based on our chart that we have here, our table. And then I get a single number when I multiply those two. Okay, I'm going to have 74 and 14. When I multiply those two, I get 1,036. And we go ahead and take the square root, and we're going to get 32.187. So on the top, we get a 21. And the denominator, 32.187. I hope I said that right. Let me cheat and look. Yes, it's correct. So when I divide those two, I get a decimal. And you should always get a number between -1 and +1. If your answer comes out 5.8, you did it wrong. Okay? If your answer comes out 1 million, you did it wrong. You have to have a small decimal, a decimal between -1 to +1. So rarely are you going to get -1, 0, or 1. Okay? So I calculated positive 0.6524. Well, that's not that strong, right? Remember we said strong is greater than 0.8. If I made a line that said here's +1, and here's -1, and here's 0 right in the middle, that's my R scale. We're about right here, okay? And 0.8 is my divider when I say it's strong. So we're going to say it's medium. So a nice medium word is moderate, okay? It's not weak. We're going to say from the 0.5s it's weak. -0.5, +0.5. So that number is going to be right here. We're going to say, hey, that's a moderate. So when I summarize or interpret what R means then, here's how we say it. There is a moderate positive linear relationship between number of children and number of televisions. There is a moderate positive linear relationship between number of children and number of televisions. We could change our data to cats and dogs, and we could have an answer like there is a strong negative linear relationship between cats and dogs. We could have no relationship, which would be 0. There is, if I had 0, I would say there is no relationship between, there is no linear relationship between light bulbs and lollipops. All right, so we could compare any 2 items. Now, this does not force an issue. This does not cause, the number of children does not cause the number of TV sets, but there's an association, and it's not the strongest association. So correlation is an association. It's not cause and effect. One doesn't mean the other happens, okay? But it's a relationship. All right, so there's calculations on doing this. The next topic we'll do is we're gonna find the equation for the line that fits right in there, the best line. So that'll be our next topic. And it's a little bit harder. Everything else is great for the rest of the semester. All right, see you everyone.